Okay. Yeah, so this session will be about process instance migration, and it's not going to be really in depth about the technical stuff that's happening while doing process instance migration, because that's not fun to do at 4:30, I think. Well, we can still do it in the bar maybe if you like. So I'm more focusing on what do we support, how do we do it on the generic conceptual level, and also show a little bit from the admin application some basic support we build in to trigger process instance migration. And if you look at process instance migration, the foundation of that, it's one of the features we wanted to have in Flowable for a long time already. And the first thing we focused on was having the V6 engine fully implemented, because that was really necessary to have predictable execution trees to really know upfront if we are in this state of a process definition, what is the execution tree you can expect in the database. And with the V6 engine we can predict that 100%. So we know for every case we can show the execution tree that you can expect there. So that's really helping when doing process instance migration. And another big piece is something we added in 6.3, and that's the option to change state. We already mentioned it a little bit, but offering the capability, if you are in a user task 2, for example, in your process instance, that you can go back or you can move forward without a secret flow having to be present for that. You can just say, I want to now go to this state in my process instance. And that's what we are also using in process instance migration. We are really reusing this change state API. And just taking a step back and looking at an example of how a V5 engine execution tree looks like, a bit with some colored circles representing executions, and then having a look how does this same process instance look within the V6 engine. As you can see, we start here with a blue execution. So basically we have a process instance execution being created, but that process instance execution is also used to go through the first steps in the process. So if you look at the execution that is connected with this first task, it's the same execution as the process instance root execution basically. And that already causes some issues, because if you would set a variable on a process instance level and you go through this and you set a local variable here, for example, it's done on the same execution as the root process instance execution. So you already have some troubles with clean separation between scopes. It gets a bit worse when we enter the parallel gateway, the fork parallel gateway. Actually, that execution that was created at the beginning, so the process instance execution, stays here. It just goes into a wait state at that point. And then 2 new executions are created to take the parallel path. So this one waits until we get here. And then, for example, the green one, we go to a sub-process scope, and we have the same issue as with the process instance execution scope. Here we create a new execution, we actually reuse the execution from here for the embedded sub-process scope, but it's also used to go through the sub-process subtask. So you, again, don't have a clean separation between the variable scope of the embedded subprocess and the execution while you are going through the subprocess. Then at the end, we come in the join parallel gateway, and then the waiting execution from the fork parallel gateway is continued, and it's taken to the last final task and end event. So you see a lot of reuse, a lot of quite strange behavior, like why does this execution need to wait at this fork parallel gateway? There's no real reason for it. But that's what's happening in the V5 engine. if you look at the V6 engine, what we do when we create a process instance, that process instance execution is kept separate from every other execution. So it's fully an execution on its own. We don't use it to go through the steps of the process. It's purely used as a scoped execution. So every variable you tie to that execution, it's really clean because it's not reused to go through user task executions or something like that. It's really something separate on its own. And then we create a child execution of that process instance execution to go through the process when starting it. And if we arrive at the for parallel gateway, there's no execution waiting here anymore because there was no real reason for it, so let's not do it then. So the first one, we just continue here, and a new green one is created here. And when we enter the subprocess scope, again, a new execution is created. So we keep the scope of that embedded subprocess really clean from the actual execution within that subprocess. So when you set a variable in subprocess scope, it's really cleanly coupled to that purple execution. Then when ending the subprocess, we create a new execution to continue there. And we also do that because this subprocess scope has ended, so that execution should be killed at that point. All the variables attached to that execution are not used anymore, they are not in scope anymore. So we need a new execution without the variables that were used here, and we continue with the process execution. And
the green dots that you have there at the bottom, there is one green dot outside of the subprocess, is that the same?
That's a really good one. So this is actually not accurate. This should be really light green or something. So this is a separate execution. Yeah.
The same as there. It's a different kind of.
Yeah, same as here. So here is orange and red. That should have been here as well. Yeah. Yeah. And this is just one example of how in V6 the separation is a lot cleaner and a lot better compliant with BPMN. But if you look at more complex examples like multi-instance, inclusive gateway, there are a lot more differences. And the V6 engine is a lot cleaner than the V5 engine. So looking at this change state API, so that's the API we currently already have. We on the runtime service, there's an opportunity to create a change activity state builder, and on the change activity state builder, you can say, I want to move this activity ID to a new activity ID, which basically means I want to move from user task ID 1 to user task ID 3, for example. That's something you can say to that change state logic. But you can also say I'm in a parallel path and I want to actually move these parallel executions to one single execution. So we can move away outside of that parallel gateway to a single user task. That's also possible with the change state API. And there are a lot of other options as well, like if you have a call activity with a subprocess, you can say I want to move from a state in a parent process to a state in the subprocess, or the other way around. I want to move from a state in the subprocess instance to the parent process instance state. So there are a lot of possibilities there. So let's look at a simple example of that change state logic. So if you go to the admin application, I think I have to start a new one. Yeah. So I created a simple example process. Let me show it. So there's a couple of of user task, timer boundary event on the sub-process, just regular process definition. So I'm now in the first task state. And if I now go to the admin application, show active instances. I have the option here to show the process diagram as well. It's just the same thing as you saw in the task application. But here you can actually click on that first task. And as I can say now, actually, I want to move that to the final task. So you see some blue indication here, red indication there. And then there, a button appears, change state. And the change state API is invoked, and we are actually now moved away from the first task to the final task. And as you can see, the first task is shown in blue, which basically means that there's still an entry in the historic tables that show that we were once in that state, but we actually jumped to the final task state. Yeah.
Does it also create an entry to show that someone activated this change state?
That there's, I think, a description or comment column used to say this was executed by the change state API. Yeah. But this is just a simple example of moving to a user task in the same scope. Let me quickly refresh this. So if I'm now going, for example, to the subtask, and that's possible as well. And at the same go, the timer boundary event is activated as well. So it's the logic that is executed is just the logic that you would expect if you move from this final task to the subtask. Then the embedded subprocess should be active as well. So the timer boundary event should be active as well. So there's quite a bit of stuff you can do here. Quickly going back. Let's just keep it like this.
So,
yeah.
If you go to the end state, anything that happened in between or did not happen in between,
yeah.
It's like it doesn't actually activate any of that. It's
no.
Just like it's never happened.
No, indeed. So it's really, if you say I want to go to that final task, everything in the middle, it's ignored. So it really goes directly to that final task.
Okay, and then when you move back, that final task will still open? Or does it cancel it? Or?
It cancels it, yeah. So if you go back, it cancels that final task and then activates the one that you are going towards.
And when you move forward, did it cancel the...
Yeah. Yeah.
I also think it's you really need to know what you're doing.
Yeah.
So it's very powerful, but it's also very dangerous. Right?
Oh, definitely, yeah. Yeah. So, looking at process instance migration and the stuff we did there, some principles we used when designing it was we didn't want to start with thinking about the cases that we couldn't support, like inclusive gateways, multi-instance, and all that. We really wanted to make sure that from the start we wanted to support every use case for the migration. So we want the end result is that we can support every activity instance migration and process instance migration. And I think with the V6 data model that should also be possible. Of course, some things won't be possible because of the BPMN specification and some other boundaries that we have to deal with, but all the flexibility you can think of, that should be possible. Also provide an easy to use API, so both allowing to use an API to migrate a single process instance with just using some Java builders or using the Java API directly, but also being able to define the process instance migration as a Json document, so that you really can design the migration up front, make it part of the deployment of a new process definition, for example, so to provide multiple options there. And the last thing is provide a way to do batch migration because if you have a lot of active process instances in a certain version, you don't want to migrate all these instances at once in a synchronous way. You want to do that asynchronously, probably using our job architecture to make that happen. So let's start with a really simple example. Doing process migration from version 1 to version 2 with start task, final task in version 1, and just an intermediate task in V2. And if we go back to the process to the app-in application, I have an example here again. Let's take a quick look in the task application. So you can see here that we have a couple of instances where final task is active and we completed start task. So we are in the final task state. If you now go to the app-in application, there's a button migrate process instance on the right hand side, and it shows the current process definition for this process instance, and I can choose another version of that same process definition and matching with the key. So I'm now going from version 4 to version 5 because I did a couple of redeployments while testing it beforehand. And then it shows both diagrams, so it shows the actual running process instance with the active state, and then the target process definition. And now I can say, clicking on final task, and then clicking on intermediate task in the diagram below, I can say I want to add this mapping to the migration. And I could define a number of additional mappings, like I want to map start task to start task in the new process definition version, but that's done automatically. So if it's the same task, if it has the same task identifiers and all that, then you don't have to explicitly map it. It's done automatically for you. So the only thing we really need to map is final task to intermediate task, and then that should be okay. So let's execute that migration. And then we see the end result of the running process instance. So we have now start task, intermediate task, and final task. So we have migrated the process instance. So if we look again at this diagram, we have migrated it to the new version, but also changed the state according to the mapping we defined.
Can you do that also conditionally? So say for a specific variable, put these on task 1 and the others on task 2?
Yeah, one of the examples I show it in a little bit shows that variable example, but so that shows that you can define additional variables as part of the mapping, because that's also quite handy. But it also we also want to add condition-based migrations as well. Currently we don't have it yet, but that's one of the goals we have. Yeah.
What happens to the execution? The new execution?
In what sense?
The variables that are defined on the earlier version.
Yeah.
Are they the same?
So if you don't do anything, then all the variables are kept from the old execution, because basically we reuse the old execution and we just point it to the new process definition version.
So it will be the same execution?
Yeah. Yeah, in principle. So the process instance execution won't change. It will have the same ID and all that. Depending on the kind of mapping you are doing, if you, for example, move from a sub-process scope to a parent level task scope, then all the child executions of that will be broken down and the other one will be built up. But the process instance execution itself will stay the same. So if you would do the same thing with the Java API, it would look a bit like this. So runtime service, create process instance migration builder. and then you define the process definition ID of the one you want to migrate to. Can be an ID, can also be a key and a version. That's optional. You have to define the activity migration mappings. So you can define one to one, you can define one to many, many to one, different options there. And then you can say I want to migrate for this process instance ID. So that's how you could do it with the Java API. Then we also have the Json document doing the same thing. So again, a two process definition ID and the activity mappings defined as a JSON array. And in this case, it's just a from activity ID and a to activity ID. But it can be, again, it can be an array of from activity IDs. It can be an array of to activity IDs. And there's a process instance migration document converter that can convert that JSON into a Java representation. And then you can again call the API to execute the migration for a specific process instance. So there are several options to execute it. And yeah, basically we went already through it a little bit. So the outcome of this process instance migration is that the existing process instance execution has a new process definition ID. So it has a new reference to the new version. The final task is migrated to the intermediate task. So final task, actually because it's a user task, we also keep the same task entity. So it's actually the same task ID by default. It just references now the intermediate task definition. And if you would have process instances with first task as the active state, they would be auto-mapped to first task in the target process definition. Because you don't have to define an actual mapping for it. They are both present in the old and the new process definition, so that's done automatically if that's the case.
And that's also logged.
Sorry?
You can also find that in log files. What's
Yeah.
happened,
Yeah. Actually, it's also one of the things I'm showing a bit later is you can also execute a validate step before doing the actual migration, and then you get that kind of feedback as well. And also the historic information is updated to the new process definition as well, because we have quite a bit of historic data possibly, variable instances, activity instances, those are also all mapped to the new process definition. And this shows the example of doing the validate migration. So instead of doing the actual migration, you could do validate migration. It's the same thing. You basically create the same builder, but instead of calling migrate, you call validate migration, and you get back the result of that validation step. And just going through a couple of other examples of how you can migrate stuff. Like I was saying, what you could also have is that you have a state where you have a process with parallel task 1, parallel task 2 being active. And actually in the new process definition you want that to be mapped to the before task that was added in the new process definition. So you want to map from multiple execution to one. So let's do that as well here. So there's a migration example 2. As you can see, parallel task 1, parallel task 2 are active. So let's do the migrate stuff again. Going to V7. So again, above the current process instance, below the new process definition version. So let's do it in the same way as we just saw earlier. You can click multiple elements here above and click one below, say add mapping. So now I'm adding a mapping from parallel task 1 and parallel task 2 to the before task and execute the migration. And as you can see now, both the parallel tasks are cancelled, and we are now in the current state of the before task. So that's possible as well.
So if you then go one step further to recreate those parallel tasks,
Yeah,
they will create new task IDs for those new tasks that are created.
exactly. Yeah,
And you'll still be able to see the old ones that was cancelled.
as cancelled. Yeah. So in the historic overview, you will see them as cancelled. So they will have two occurrences then, one being cancelled, one being active at that point. Yeah.
Sorry, and then the before task gets a unique ID, or does he take one of the parallel tasks?
No, that's because it can't automap it. It will be a unique ID. Yeah.
And this also works for the case where the parallel one of them is completed, or does it have to?
For the first example, you mean, or?
No, in this case, let's say one of the tasks were completed and it's waiting for the
Oh.
one to go.
Yeah. So in that case, this specific mapping would not be hit because it really has to be both should be active. Only then you get a hit, and then the migration is happening. So then you would have to say if there's only parallel to task 2 being active, then I want to migrate it to this state as well. But it's a good example as well as something we should cover indeed. Yeah. This again shows that you can do the same thing from the Java API as well. Nothing too special. What we also support is moving to a different scope, of course. So moving from the after task here to the script task, because until now we have moved from user task to user task, but that doesn't matter at all. So you can also move to a script task, to a service task, anything. That really doesn't matter. It just demos a bit better if you do it on the user task. So we now go from user task after task to a script task in an embedded subprocess. And you can also define variables as part of that migration as well. So looking at that from a Java API level, we can use that activity migration mapping helper class and create a mapping from user task from the user task to the script task. And you can say with variable or with local variable and define the variable you want to use there as well. And everything else happens in the same way as we saw before. You just have the option to define additional variables here. And you could imagine that you could also have the option to remove variables, because that's also necessary, of course, that you could remove an existing variable and just make sure it's not there anymore. And one thing we are now working on, and that's coming as part of 6.4.1, is a more advanced case where you would have a parent process with a subprocess instance running. And what you want to do is you want to move the state from the subprocess subtask 1 to a task in the parent process instance. So there's a really collaboration between the parent process and the subprocess instance, and you can move the states between these instances as well. What we decided is that if you want to not go to the parent instance or to the subprocess instance, but let's say you want to move subtask 1 to subtask 2 for the subprocess instance, that we don't do that from the parent process instance migration, because you could do that directly in the subprocess itself. So if you want to move this to a new version, then you could use that as a process instance directly as well, so you don't have to do it from the parent process instance.
The other features are available in 6.4?
6.4.0. Yeah.
Yeah.
The only thing, so the one that I was showing in the app and application, that you can do that in a graphical way, that's coming in 6.4.1. Yeah, this shows the example of doing the parent process mapping or the subprocess mapping to the parent process. So there's a bit more logic involved. So you have to define the call activity ID for which you want to do that. But in the end, it's the same kind of API. So closing it up, there's more support coming in 6.4.1 and also after that in 6.5.0. But really the basic migration support is already there. What we are adding now in 6.4.1 is support for call activity migration, so really the parent process to process instance migration. Also multi-instance migration. So that's where we did some improvements in the dynamic state manager because we also encountered some issues there. Then in 6.5.0 we want to add support for the batch migration so that you can define on a new deployment, for example, that you want to migrate existing running process instances to that new version directly with the Json document, for example. That's coming in 6.5.0. But what for us is really important, so we have quite a number of unit tests for this process instance migration, but actual usage and feedback from you guys as community members, that's really important for us because that can really guide us also to focus on certain features. So if there's any feedback in the coming months or so, please let us know because that's really valuable for us.
Is the API available through the script task? So if I wanted to write a process to batch transfer my...
Yeah, basically it's available on the runtime service, and you could access the runtime services as from the script task as well. So in that sense, it is, yeah. Are there any questions left? Yeah.
When you change the activity status, one activity to another, do we still have the transactional state possible? Is it possible to have an error transitioning and come back to the previous task?
So the full migration on the process instance level is fully transactional. So that's one transaction. So if anything happens that makes it fail, then the whole thing is rolled back and you are at the original state again. So it's either you are fully in that new state or you are again in that old state again. There's no multiple transactions going on or something. Yeah. Okay, thank you.